last lecture in this semester. So today we are going to talk about two things. The first part is about the homework. So this is our last homework. We are going to rendering something by using number and numpy. So just like the previous homeworks, we are going to draw something. But this time we are more focusing on the technical detail. That is, you don't need to create your own content, but we are going to use some pre-existing 3D object model files, and we are trying to render it as a 2D, two-dimensional image. So you don't need to worry about to create new content or drawing something like the first one, but more focusing on how to render the 3D model files efficiently. So like the first homework, we are going to use a numpy array to represent image, and then you can show it by using either the like Pillow or like OpenCV. Let me show you the homework site. Okay, and about the second part we are going to introduce more softwares about the data science. Well, mostly about the parallel or distributed softwares that related to data processing and distributed computations and related to machine learning or other tasks. So we are going to talk about like Ray, Scrum, Desk, and maybe about Redis, salary, those kind of things. Okay, but before that, let's focus on our first part, the homework. So let me link to the homework. Okay, now there's no link. Okay. So this is our homework page. You can go to the website, the course website, and the link in this week's link, you can find the homework 5. This is about accelerating point cloud display using Numba. So first of all, the goal is kind of like this one. You are just going to render the vertices in 3D model files by using the NumPy or Numba directly without helping of like, we know that Matplotlib has a 3D display function that you can use it directly, but we are not using that. The intention of this homework is to let you to write code about a task and compare the performance by using NumPy alone and by using Numba to accelerate, to optimize for the speed. So we'll see that. I'll give you a demonstration about how to do that. But the final result should look something like this one, or like this one. These images are a little bit higher resolution than you see on the screen, so it may be something look like this one. Okay, like this one. So just to give you an idea what we are aiming for. So how to achieve it? First of all, you should obtain some 3D model files. The file format I am suggesting you to use is the .obj file, which is a wavefront obj file. You can find a lot of 3D models freely, or if you want to pay, you can pay and get them legally to use in certain task or in your creation. I've given you 2 links that is freely available especially the first one. The first one contains several classical standard test models, like the rabbit. This is a Stanford bunny, which use a lot of in like com, uh, com, computer graphics in 3D rendering, and of course the T part. I'm not exactly sure this is the Utah teapot, but kind of look like it. And this one is the Susan, which if you use the so for like Blender, you will see this one. Okay, so as a typical demonstration. However, for Susan, this is not a good choice in our homework because it has too little vertices. It is a simple model. In our homework, we are trying to use the vertices in this model as a point cloud. So you you might want it to have a lot of points, a lot of vertices, instead of just a few. The Susan is not suitable for this case because it has too little um, vertices. So it does not display very well, and it might not be able to demonstrate the improvement or the performance gain from the non-bar version. So I suggest something the Stanford Bunny is okay, and other models like Bimba, Lucy. Lucy is like this one. Um, this one is a Stanford Bunny. I render it in a different way, so it seems a little bit lighter. But the bunny has plenty vertices that can be rendered uh, pretty well and enough to show the differences between um, the NumPy version and the NumBar version. In a homework demonstration, I'm going to use the bunny. And other files you can download from other site, like this one and this one, or this one is from the other side. This one contains. This is a model of the Bugatti car. It has a lot of vertices, which is very good, very suitable for this homework. Except it has a lot of vertices in the background because they are like environment. But if we are only going to focus on this car, you have to scale this kind of manually to focus on the car itself. And this one is a Lucy, exists in the repo that I just showed you. And this one is a Beast. And this one is another, um, perhaps Bimba, I would say. So there are plenty of models in here, and maybe some of them are not suitable, but you get a lot of choice from here. Another choice is the let me find okay here is Objectives. It is a collection of 3D object files that you can use. It has a collab. It only contains the link, not the OBJ file itself, but it contains a lot of different 3D models. Some of them are OBJ files, some of them are in other format. You will see that OBJ file is very easy readable and comfortable. So I'll suggest you to use these OBJ files because you can use it in Python without any third party or library to help you parse or um, to get the vertices from the model files. So you can use OBJ files and do the parsing simply by purely Python. However, I mean in here it will show you. I think I got the notebook here. So here is my modified notebook. So that I can get a link here. So you can see that this is also my modification. You can see that it contains a link from different sources like GitHub, ThemeFirst, Sketchfab, or other things. Like all of these are pretty good source for getting free and legal 3D model files. But some of not all of them are presented in OBJ style. In Sketchfab, there are a lot of files provide different format, like in GLB or OBJ. But in this collection, they use GLB primarily or exclusively for the Sketchfab. You can definitely find some OBJ file in Sketchfab. So for example, if you log in into the Sketchfab, you can actually simply search things like OBJ. Might just work, and you should click the download because they can provide files to be downloaded. Some of them are not free. You have to buy them, but I'm not sure it has a free. So for example, this car, you can find the download button right here. So you can simply click the download and find the OBJ file to download. Then you can have this one. But not every model is suitable. You need to have enough vertices in the model files. So if a model looks kind of complicated in shapes, so it might have enough vertices. Not everyone is suitable. I guess this one might be suitable, but I'm not sure it has a download. You might need to purchase this model, but okay, it is downloadable. But you might want to purchase because I didn't see the button right here. So some of them are downloadable, and some of them may need to have payment. This one might not be suitable even if it is downloadable because it only has. You can imagine it doesn't have enough vertices count. Okay, so that's it. You can find a lot of models in Sketchfab or in the repo that I presented before. There are also something like the OBJ file that is from scan. Okay, like maybe this one, but this doesn't seem to have a download link. Okay, you needed to search a bit and see the download link. Okay. But if you are not restricted in the OBJ file, there will be a lot of different things. Like if you want to have a car, simply just want a car, or maybe this one. So if you click download, you may see that it is existed in different format, but there's no one as OBJ file. So you can actually download the FBX and use other tools. So for example, Blender can do it, but there are also other converters to convert it from FBX to other format. There's a MeshLab viewer can do a lot of things. At least it can help you to visualize the thing. I think it is in both in Windows, can work in Windows or in Linux. So you can use a mesh viewer on like MeshLab to do a thing. I'm not exactly sure it has a converting because I'm not using it, but it might be able to do so. So So other choice is to download files in other format and convert it into OBJ file. Okay, so what is an OBJ file? There's a I provide a link to the Wikipedia page right here. You can check the Wikipedia to see its format. But we can actually look into one of the files to see what it is. So here, fill the role. Okay, so it is text file, so it is human readable. You can see the V stands for vertex, and these three numbers corresponded to the x, y, z coordinate of this vertex. So it's quite readable. So you can actually parsing it easily by using Python. That's all. That's all you need to do. There are other lines that start with different letters. Like some of even start with VT or like F stand for face. Let me go to the bottom of it because this is a rather large one. Okay. So there are other like F stand for face. Because this one is actually pretty simple. It is a triangle that it has three vertices corresponding to the vertex that we get before. Like you start from the first one, second one, the third one. So each vertex has an index. So this corresponded to the index of vertex. And you go back to the vertex to get the coordinate. So you get the three coordinate of this triangle in the 3D space. And it has other information like which material you should use and the material coordinate to each of the vertex. So you can see a Wikipedia for other demonstration, like they have VM, VT, T for the texture coordinate, the N for the normal, and P, what is P? Parameter, some kind of parameter. Those are polygons. But we only need to parse for the line begin with the V and a space. And we get these three number as our x, y, the coordinate. We ignore all other things like materials, like the face or like the normal. We don't need those kind of things. And they also has a comment. This is also in the file because if some lines start with a hash, it will consider as a comment. We also ignore all these comments. Okay, so after we get these OBJ files and we can parse it, so we get a point cloud. Essentially, we get a list of points, 3 points. Then we want to use some projection to visualize them in the we want to visualize them in 2D canvas, like a viewport. Okay, so I kind of hesitated or paused a while because there are actually a lot of different sources to get 3D files and object freely. I kind of thinking about whether I should give you more information, but okay, I think you can Google it and find more models. So we're going to the how to actually render it and parsing it part. I'll show you in the code just in a while, but let me first give you an overview about what is the instruction. So our goal is to render 3D point cloud in NumPy array, and you can choose either orthographic or perspective projection. I will show you in orthographic projection because it is easier, and I think it still got what we need. But in order to see the benefit of number, how easy it is to write a code, it might be a good idea to use like something like perspective projection, and maybe even like a debugger, or maybe doing a full rendering has a texture or that other thing. And you will see that when the algorithm is getting more complicated, it will be start from some point. It would be easier to write it in more plain or ugly code like number, like a loop, instead of doing everything in NumPy. Even though you are very familiar with NumPy, times comes that something begin to be start to be difficult to write in a more elegant or mathematical way to write the code. If you write it in a loop, it will be easier to do the modification and adding some new feature. So even if you I figure out one elegant way to write the code using NumPy, and maybe later on you want to add some feature. In this example, you may want to change it into a perspective projection. That one might be still easier, but something like if I want to do the material, I want to do the texture mapping, I want to do the debuffering, or where I will show you a little bit later, to do a different level of the shading, like the brightness. It will become a progressively increasing the difficulty if you're writing in a NumPy style. So even if you figure out how to write it elegantly with the original plan, when you want to modify um the the code, modify or add some feature or modify some parameters, things are going to become differently. Because if you want to write a code very elegant, it requires some planning beforehand, because slightly change will affect the design of the things. However, if you write it in a more coding or programming styles like Number, it will be much easier to do a change, because there were just a few patterns like for loop. It cannot change too much. It's just a for loop. So you modify contents in a for loop. It won't. So it will be easier to change. So I mean, this one applies to the data science scenario or machine learning scenario or research scenario a lot. Mostly for every science scenario a lot, because we don't know exactly where we are going to heading for. We are going to experiment or exploring a lot, because so writing the code in the more, we will say, the ugly style, or like spaghetti style, or like the um, non clean style, will be easier, even easier, to maintain or modify, to play with. But still, there are some rules are still apply to help you to do things. But there are a lot of clean code style. It does not apply to the style to the scenario when you are going to experimental or try or modify things a lot. Okay, so this homework demonstrate some of this aspect. Okay, so after we get the okay, let me explain a little bit about what is orthographic and projected projection perspective projection style. Okay, so let me just show you a few pictures. This graph shows the differences. This one is perspective, and this is also graphic. And this one may be a little bit easier to demonstrate what it is. So when we do the orthographic projection, it's quite easy. We do the we simply choose the two of the axes directly, like this one. We just ignore the, in this case, there were three axes, right? Let's call this x, and this is z, and this is y. We kind of ignore the x direction, use only y and z, and that's it. So this projection is easier. However, by using the perspective projection, we are considering we have this is also called the pinhole model. When we have a pinhole right here and a projection screen, so we have a straight line between every vertex we want to rendering in a 3D set and project by using this straight line to the projection plane. So this is perspective projection. We kind of modeling our vision primarily using this perspective model, like a pinhole model, but and also like the camera, an ideal camera is using this model, but in reality, the camera would have distortion and other parameters need to be tuned. So we introduce when we talk about the computer vision, we talk about the camera calibrations. There are several things need to be calibrated, like how far and how large is this projection plane, or what is the viewport of this one, and other parameters. And also we want to calibrate the distortion. That is the imperfect design. I mean a non-ideal, non-theoretical design of the lens that we are using in a camera. But anyway, this one is called the perspective projection, and the former one is also graphic projection. You can use either of them, but the orthographic projection is much easier. So we are going to use it. But there's there's nothing wrong if you are going to use a perspective projection. It's just a little bit difficult to do so. Okay, so after we know the principle, we can actually do the rendering. The first one, we can use the NumPy. Of course, we can use the NumPy to do that. It's not too difficult. And you will have, this is, you have to render. Let me put this one in bold face, so to emphasize that it's something you need to do. I modified the original one, but it will not show it directly in here. Okay, but anyway, let me try to reroll it to see if it works. Okay, it works. So render the object from 5 different angles, because you can move the camera or move the object. So try to use different angle and different position of the camera. The easiest one is to doing the rotation. Because if you just move in or out, it will just scale the object. It doesn't do much things. So you have different angles to these models. You can see different faces of this model from different direction. Okay, the first one, you just show the images so that we know that you can actually do the rendering. Okay, so one thing that you submit, as usual, submit your work in the notebook. So render 5 different angles to display the model. Then you run the rendering 1000 times to measure the runtime. You don't need to actually generate the image, I mean, to display it on your notebook because it will be too large. But it will be helpful if you can display it in animation when you do the coding to see it actually works. But in the notebooks, in the final notebook you submit, you don't need to render these 1000 images at all. You only need to measure how long it runs so that we can compare to the non-bar version. Okay, so the non-bar version does pretty much exactly the same thing. You do the rendering for 5 different angles to show it, to convince us that you actually make it work. Let me reload it again. Maybe it is cached. Okay, it works. So this one too is something you need to do. Our goal is to actually speed up it, so you can use anything like fastmax, parallel, non-Python, non-GIL, or even if you want to use CUDA, it is a kind of thing that you can try. Okay, after you do that, do the comparison. So okay, the thing that you need to put in your notebook, I put in a boldface. It's the last one. Compare the speed up factor. So sometimes if you didn't do it correctly, it might be even slower than the NumPy version. So give me something that you can speed up the things. So show me the speed up. How much the speed up is. Use any kind of format like 20% improvement or twice as faster, or using the time use like 30%, only use 30% of the time, things like that. Any way that compare the speed or the time measured in these two versions, it's fine. Okay, so right now I'm going to show you the code. Okay, so I actually clone the repo. So to the repo that I showed you before, it contains a lot of data here. Contains a lot of different the repo. Let me show you again. The repo. Maybe I can link to it again. Okay, so here this repo, it has in its data, it has a lot of different object files. Okay. Okay. So I clone the file so I can use them easier to use them. So I'm using the Stanford Bunny object file as an example. So first of all, I import everything, most of the things that I think are necessary at the beginning. Then I do the parsing. The parsing is quite. Let me put this one on the below so I can focus on the code and output altogether. Okay, so this one is I use the pathlib a lot. So although you can directly using something like obj open the obj fn and read things directly, you can do that. It won't be too difficult. You can see that this is for a few lines of the Stanford Bunny. Okay, as it shows, it also converted using Mesh Lab. So if you got the 3D object model, 3D model files that you think you want to use, you really like to use, but it is not in the OBJ format, you can use MeshLab to convert it to OBJ first. Okay, so I can actually read it and using speedrun, but I kind of like using the passive functionalities like read text. So I use this one to get the vertices. Okay, so it is pretty easy way to do that, and then convert it to NumPy array directly in just one line. Although I split the code in several lines, but it is just one Python logic line, and I filter out all other lines that begin with the V. You can actually use pandas to read it because it is essentially a space separated file, but because it has a lot of things need to be handling, so I just think it's perfectly easier or fine to use the pattern that I use here. Although you may want to use other way to read the files, like using the read, like open this file and loop through this open file, it will loop through the lines directly. Okay, anyway, we got the vertex. This is the one of the easy part, and we can see the vertex shape. It has like 35,000 over 35,000 vertices. As we see that it actually has a contains a high resolution. Okay. Origin data. Okay. I'm just thinking about whether should I change the file that we want to use. Okay, but anyway, we stick with the Stanford Bounty. Okay, so anyway, we need to, this is already a data. We need to do everything we have told you about the data. When you get the data first, you see the shape and D type. But this is float, I know. But it won't be hard to check the D type again, and you can see that it's float 64, like a double in Python. And we want to have some statistics about the things like how large, what is the maximum value of it in each direction. So like X, Y, Z. So it is something between I mean, this is the maximum. So let's see the minima together. So it's something small. If we want to scale it into like a 500 by 500, we need to do some scale, and we need to do some shift to move it into the positive things. So when you see these numbers, you will get some idea of what you will have to do a simple estimation. And we can also find the mean of the things. Another way to do that is like we might talk about before, like use the SciPy function to describe the data. And you can see all the things above directly, like variance, skewness, kurtosis, and it doesn't show the percentile things, but it shows enough information already. But anyway, I myself use, in this case, I want to see the max, minima, and the mean, which is quite enough in this case, because that is something that I'm going to care about. Okay, so let's do a quick projection experiment. Really quick, because there are a lot of things we need to worry about before going into the full perspective projection, which we are not going to. But I mean, theoretically, that's what we are going to head for. But because of the time limiting of the homework, we are not going to do so. But even if before we go to the orthographic projection, the true one to do every angle, there are a lot of things we need to worry about because the data scale is kind of strange and we're not familiar with the data. So we need to do some visualization to the data. So one way to do that is using the Matplotlib to actually visualize the things, which like use this one and the PLT scatter, like these two. Okay, so you already get the bounding things to see, and because Matplotlib automatically change the scale, you can see a rough image of it. Maybe we should move things, change things a little bit to make the alpha to be 0.1. It seems better, and the S to be 1. Okay, so in this case, this can be like this one. Okay, so we get a rough image. So even though it is not what we actually exactly want, to do a quick preview to see what your data is, this is really important to do so. Even though we are not using, like I explicitly said, not using the Matplotlib functionality to do rendering. So that is not a choice, one of the choice, but you still can use any tools to do the quick visualization to see what your data is. Okay, anyway, let me okay, so I want to rearrange this one to be easier to be visualization, or maybe still like this one is still better. Okay, so as we already know that it can be shown, let me maybe doing it in into a NumPy array. Okay, so I'm creating a NumPy array, and first of all, okay, so I'm thinking about an image that is 500 by 500. So I create an image array right here. But because we need to do some scaling. So what I'm doing is I'm making the vertices. I'm still looking for the first four dimensions. The first one and the second one. But I'm making it 1000 times bigger. And because some of the values are is negative, which I probably does not need to do so. I use this one directly. So I do some experiment on the scaling and show the image. Okay, so this one is purely doing menu and doing things like you can adjust and see what happens. You can do some calculation. We'll do that later. But before that, doing some of like modification, hand modification is okay. So you can see that, okay, we got the bounding right here. It might be a little bit too on the right, and let me change the first one, see what it happens. Okay, it moves a bit, and maybe we should do, okay, at least in not the right direction. So maybe we should put in another one. So that's it. We're doing this one in a very, kind of a dumb way to adjust it, but it sort of work. Maybe we want it to be a little bit larger. So I put it like 2000 and change it again. And this one is still, okay. This is the x-axis. So okay, so maybe this one. Okay, so we got a rabbit in our view, which has a reasonable size and more or less in the middle of this viewport. So this scale is probably something we want. Then we want to write some code to sort of rotate it. At the very beginning, we probably want to do something simple. And for a homework, it is kind of enough to do so. Like we only rotate we keep the y-axis, but rotate the x and the z-axis, so we can rotate the bunnies. We want to rotate it in 360 degree. So we put, okay, the scale is 2000 like this one already. And 345, we use the parameter we use above. Every time we get a rotated x and y first. Okay, so when we do so, we use a simple formula right here: cosine times the x value and sine times the z values right here to get our rotated x, and our y-axis we keep the original one. And finally, we put them together. So we stack them together and put them together. So we'll see what happens. And because we are planning to use fancy indexing to assign to the array. We already construct the image array at here. We want to do the fancy indexing. So the index should not be over 500 or equal to 500, because the index is between 0 to 499. So do a clip to force the values to be in the 0 and the things we want, like between 0 and 499. So here is a kind of ugly things that if it is over 500, it will become 499. So we will see a straight line. If it is over like 500 or more, it will be clipped at 500. So you might want to see a straight line on the border of the image. But so the ideal way might be filter out these things, but I figure this might be a little bit slower. So we choose the slightly defect or inconvenient part to make it faster. So anyway, let's see the result. So anyway, we use fancy indexing here to assign the value, like the pure white, to the vertices and see what happens. Okay, so I'm using OpenCV. You can see it is rotating. So see that here I use a wait key here and destroy all window right here, so that we can have a final view of the rabbit as it rotate and see how it end. And after we press another key, it will be, the window will be disappeared. You can see that it is pretty much rotating a rabbit in different angle. So you can see that. So that's it. But we haven't measured the time. So after we already know what we are going to do about, we are using uh, write the major part in a function right here to simplify the things, to separate the things, or to organize the things. So we define a function called the rotate and project MP, which is exactly a copy of the things here. So here we also demonstrate the things that when doing exploration or experiment, and when doing things in a more program coding things like deploy or packaging things. When we do the experiment, we write things in lines because we haven't yet figured out or sure what we are going to do. So it is perfectly fine to writing code in a more like a spaghetti. This is not a spaghetti, but this is more plain or flattened way to do things, or maybe a lot of nested if else for loop. That is totally fine because we nobody knows what we are going to do yet. We need a lot of adjustment and experiment before we can make sure. So after you got an idea, but you have to have a mindset to organize things. But for some problem, it's too difficult. That is too experimental and adventurous. You probably will have less idea of how it works. You just write things that plainly on here, and after you make things works, and the code is getting complicated enough, and you learn some idea, you got some idea and learn something from what you have doing the experiment. Then you do the things like this one to organize, to refactor the code. Or that's what the things when you're doing the science or experiment, you always start something messy and then organize it into a few concept. And after you do that, still do something messy in other place, but you can do that in a more efficient way because you have some small unit of things that you are sure that is usable. So this one also demonstrates the progress of things. So after we have some idea of things, I mean at the very beginning we have no idea. So this is for first phase. We kind of showing it and adjust the scale things like here. So this one becomes this one. This one becomes this one, and the reason that we didn't make it function at the beginning is that we are not sure this actually works before we can make it wrong. So after we make it wrong and make sure it works, it is perfectly fine to actually pack it into a function. So right now, we use it a function. We can do the rendering, the do in here. Well, I'm doing the rendering using another method. I'm using rendering using the IPI widget. You will see that it is not in the OpenCV window because OpenCV window is actually pretty slow. So and it is not integrated well with the Visual Studio Code. So I'm using it using the GPU Notebook widget so that I can see it directly in the. Let me make it longer so that we can talk while this is running. I make it turn like 20 loops. So I have time to sleep, make it doesn't go too fast. So I'm using IPI widget and calling this function because right now I'm pretty sure this is what we need. But the thing is, it is not exactly what we need. We will show it just a while later. But anyway, OpenCV is quite slow. IPI widget is slow, but the OpenCV view is slower than this one. The IPI widget is slower because it is web-based. So you need to encode like here. we encode the image into a JPEG in a PNG format, and then send it to the browser. Although this doesn't look like browser, this is a browser HTML rendering. So it require transfer some data from your program to the render. So should be slow, but even though we are doing a lot of things through the network, it is still faster than the OpenCV, which you see before. But anyway, this one you can see that it works perfectly, and because we are packing it into function, we can simply focusing on the timing things or display things. So like you can see that I rotate it in 7,200 iterations. Okay, so we can see a total time it only takes 70 seconds. So let's measure it 1,000, because rendering things will affect the time measuring. We want to make everything to be perfectly measuring the performance only. Okay, so I think you know how to render 5 different angles already, so I'm not going to cover that. I'm going to cover how to actually measure the running time. Okay, so in here, by running it, 1,000 times, let me make it 1,000 times. It takes 2 seconds. So this is a NumPy version. The NumPy version is not too complicated, and I mean you can see that we do the rotation a little bit, and doing the projection is pretty easy. But that's all. And doing the fancy, probably a lot of time is wasted on the fancy indexing. So we probably will get eliminate this fancy indexing. But anyway, it took 2 seconds. Okay, here we take 2 seconds. Now let's write a number version. You can experimental and write a different version. But here already has a number version. I actually worked through different iterations and different versions. Originally, I replaced everything but keep the fancy indexing. It will have some speed up, but not much. And but as I mentioned before, a lot of time might be happen at the fancy index. So the final version, I am get rid of the final indexing. After I construct the image here, you can actually construct image outside the number. It might be get faster, even though you have to pass the image right here. But I stick with this one. It is simpler. So I construct image right here, and I write a parallel loop right here. And I don't need the fancy indexing because every time I got the index, so I compute an index for every different vertex. So every time I got the index, I don't even do the clip. I just check whether if the index is in the range. If it is so, I assign the index to the image to be here. So you can see that I can get rid of the clip because I don't need to worry about the efficiency, and I just use the if else. It works just fine. So here is the final result. Okay, so the first time I haven't run it, I just declare it. So the first time run it, you will see that it will take some time to compile. So even though it only run like 360, it takes 2 minutes. 1 second. But after the second run, you can see that even I run like 1,000 times, it only take like 0.25 seconds, like almost like 8 or 10 times faster. everyone will be a little bit different. But you can see that you don't have to do things like this one. You can simply estimate time. Like let me do it again. So I'm writing in this way because I want to measure it when using the UI generation. So I'm doing this way. But since you can actually time in the actual loop, so you can actually do the things like this one. Or like this one. A little bit longer because it will include but not much because it will include only the for loop things like it still need time to do the for angle in range things and it actually but the difference is minimal. Okay, anyway, another ways there are also time it functionality to in Python or like in Python. I mean in Jupyter Notebook in IPython, it actually has a time it. Let me run it just in one time. We can use time it, and you can see that the result. Like, if you want to do like run it, repeat 10 times, so you can see that okay, it's pretty standard. I mean stable at this speed. So you can also use time it, but any reasonable way to measure the performance is okay. So for the homework, this might be just fine to do that. Also, this one is the OpenCV version. It works, seems okay. But we can do a little bit more. How do I do here? Okay, this one is also okay. So because this one is only rotate in one direction, so maybe I want to it rotate more like freely, especially for other because I'm only work these things for Bunny. So every parameter is adjusted according to the Bunny file. So if I want to make it more freely, so some model is presented in other direction, like the Lucy one. It is a status, angel status. It doesn't stand like the from up to down. It like this one. So if you rotate it, it would be kind of strange. So I want it to rotate more like freely in different direction. So I make a strange trajectory for rotation, like this one. This is kind of arbitrary rotation, but it works. So the rotative function is a little bit more complicated here. This is standard rotation in three, like a pitch, roll, draw, like this one. But other than that, it is similar. But also, maybe I should just make it 255. In this case, I'm using a more complicated. I mean, this line we are using a more complicated way to do the rendering because there might be, say, for if the model is very dense, it has a lot of vertices. It might have a lot of it might have some of the vertices that's located in the same position in the 2D canvas. So I want to so every point is not does not contribute to like a full 255 intense of the lighting. It only contribute to like 80 of it. It can be adjusted. And when it is accumulated accurated to more than 255, it will cap at 255. But anyway, I'm using the 255 right here. And let me use another object, beast here. So you can see that the trajectory is kind of arbitrary, and you can see a lot of different angles from it. So it runs more smoothly. We can use other models. Oh, okay. Also, I compute the scale automatically from the statistics. You can see right here. I also increase. I also increases the size of the image. Let me run it again so that you can. Maybe I should write it here. Okay, so that seems better. Let me choose another object and maybe I make it running longer, like 2000. So this is a status of an angel. You can see that it rotates like this one. Although there are other models as well that you can choose. So like I said, I changed the viewport from 500 to 800 to make it more, to show more detail. Let me clear it. And also there are like Bambi. Let me check the file. Oh, let me show you the dragon one. XYZ RGB. So this is a dragon model. With only these few lines of Python, you can actually render things pretty easy. You can actually change the color of the each vertices to running through like RGB sequence. Okay, so why not just make it more freely controllable? So here is another simple that you can do to actually, let me use the XYZ RGB. Dragon. So in fact, you can use like this one. Let me make it larger. Maybe I shouldn't. So with some API widgets, or you can use it like a keyboard control. Totally fine to use keyboard control or to adjust different angles of this model to have it to be in a perfect position. So this is what IPL widgets can do. Let me just put another example as the final on this one. Okay. There's a building one. Okay, I actually want to show you the building one. there's a building one here, so that I can demonstrate let's okay. Let me change the file name. Oh, this one is a larger one because this is a building and has a very dense structure here, right here. Let me put it here, and as you can see, it is a building, and we can rotate it in different direction. I actually want to show you more dense things so that we can adjust the density of it. So maybe this is not a good example. Okay, so maybe let me reduce the, we use Stanford bounding and reduce the size to make it more dense, like use the Stanford bounding. Oh, maybe we use another one. Okay, we use this one. Room test queen black. Copy this path. We use this one. I'm trying to use someone more dense so that we can show the point of why I should do that. Okay, so this one is quite dense. You see it is too white at each point because it has a lot of different vertices. So we cannot see the detail easily. So we wish to, because a lot of points are in the same position. A lot of vertices are in the same position. So we want to make it. We already got the, okay, here. We make it, each point has less intensity. So after we get this to be less intensity right here, not 255, every point has less intensity. Then we can see the detail, more details. But I think we can still go further. Maybe we should just go to the like 5. Okay, so you can see that the human body part is more visible, not just a bunch of white things. It is more like different level of shades. You can see it is more okay this way. Rotate it more in a better way to do that. Like we want it to be rotate like this one. Okay, so we can actually even go further to make the human part more lighter. Still make it lighter. If 5 is not enough, let's put in 1. It might be too light, but we already then we know that the correct value should be between 1 and 5. I think it's okay. Maybe the one is not too light. It's something. It is something. I think we pick the values we used before, like this one. Because we are using a very low resolution, so that's why we need to choose this more extreme value. Okay, so this made it more visually present than before, and we can actually do some modifications. So right now I'm just giving you some example to see why we need some experimental and modification. So right here, we probably need it to be like we want the image to be like a green one. So like more like the old monitor CRT monitor feeling. So I can do that. It has to be at the first time. It has to be need to be compiled a little bit, but oh, okay. Let me check what happened. Okay, NumPython, the number part is not working here. Okay, here. I see. Okay, so it got a feeling of like the retro green monitor things. You can change it to other colors as well and have some okay visualization. Okay, so that's the homework about the homework. So I believe I'm gonna present the code in the repo so that you can work on your own. But I think already provided enough information for you to feel comfortable to finish the homework. And maybe if you feel a little bit adventurous, you can try something more difficult, like say things like what I do, like a slider things, or doing it in perspective, in a perspective projection, things like that. Or maybe you want to apply the material in the, I mean, there will be a, there is a, you can assign vertex color to each vertex. That's one thing. You can actually do that with MeshLab. So you can read that and get the color of each vertex. You can get a color of each vertex, and then you can render a color, point cloud, things like that. Or you can read it from the like the material file, texture file, and get the color of each vertex. That's one thing to do that. If you already got something with a texture, you can actually bake the texture into a vertex. I'm not entirely sure that the MeshLab can do that, but Blender can do that, and there are some Python libraries can do that. So you can do that by back the vertex, I mean the color into the vertex, and you get a vertex color. Then so you can render a color point cloud. And in that case, you might want to use that the Z buffer, or maybe you want to do even more, like considering each point to be a small ball. So if it's getting far away or getting near, it will have different size. Maybe you want to do that. Then it is also doable, and then you can measure the different size. But anyway, I think if for the basic requirement of homework, you already got all the information you need. The Yeah, so I think it's really good example that you can try to do the coding. Okay, so let's go to the second part. Let's go to the second part to introduce more okay. slides right here. Let's go to the slides. So at the this is the end of this semester, so I'm going to introduce more libraries that you can use. There are a lot of libraries for doing data science things. A lot of softwares that you can use in data science. We introduce a lot of different major ones. Some software and library related to the one that we introduced. Like when we introduce something like scikit-learn, we also talk about the things even like Orange or other libraries. And when we talk about pandas, we also talk about like Polars, DuckDB, or Dask. So there are tons of different softwares that you can use. There are also like AI related or large language related. We cover some of them like PyTorch and Hugging Face ecosystem and PyTorch things. So everything, but there's still a lot more. So today we're more focusing on the distributed computation things like message passing or like cloud things or like HPC things. So this one is Ray. So this is a way for doing distributed or remote computations and other things. The basic idea, I think the fundamental things about the Ray is the core function. It's a core functionality that is called the Ray core, which is enabled to scale up the apps to build them in pure Python. We will see that in a short while that you can see how to call a remote function to get that idea. But based on this core, it can do a lot of different things and can extend a lot of different functionality. Especially it is currently focusing on the AI. Like, okay, it has a core and it has some fundamental object like tasks, actors, and objects. Built up on these core functionalities, it can apply on AI scenarios. So it has a different sub-modules like data for data processing, training, and the tuning, and the serving, and RLib. So this is the core functionality for the Ray, what we know for. So basically, you got a remote function. You have a Python file, so you import Ray. So you start to initialize the Ray using ray.init, and Ray you use the decorator Ray remote to decorate this function. Then you can run this function in a remote machine. You need to set something about your configuration since your machine. If you want to have some certain configuration or of your cluster, but it can do things like this one. Even if you on a single machine, it can do computation in a client server way to do a parallel, and it will do it automatically. The selling point of Ray is it is easy and easy to use. It, in my opinion, it is also this approach, this kind of the weakness of this kind of approach, because it hides things behind the scenes. It will make if you write something easier, really quick, kind of like in some sense, it kind of like the Hugging Face, Gradle interface, like it has an interface function to write a short user interface really quick, but it hides something magically behind the scenes. So you are writing the remote code and the client code in a same file, and you probably wouldn't even aware of that the message is getting passed from here to there. The Ray actually have some consideration on this, so it is, you can see that we don't, even with this decorator, we don't call this function directly like fi. We call it f.remoteI to emphasize this is a remote function. But for convenience part, it's still just in one file. So the good thing is it helps you to understand the flow. But the part is you have everything have to write into one piece. The definition. We will talk this more about when we talk about the salary things. But this is because sometimes we want to hide the. I mean, we want to hide the server implementation, and or maybe not hide. We just want to separate the server implementations and the the kind part. You only need to know the interface to the server, not the full definition of everything. But in here, I mean, if you write in this way, it will the client see everything. The client already see everything right here. It's not just a function; it is a function that return x times x. So sometimes I mean, a lot of times it is easier because um, you just write things like almost like you write things without the remote functionality. But because remote functionality is kind of complicated, you need to have a message passing. You have to have your object doing serialization. In it underneath, it will still have a server and a client and the passing object. Everything will exist. So sometimes you want to, I mean, one thing is sometimes you want to have a client in one language and the server in another language, in a programming language. So they have to be in a perfect different part. So you want to kind of separate the client and server. There has some reason why we want to separate the server and the client. But in this like server and client mix up together things, it has its benefit and its drawback. But definitely it can be separated if you want to. But Ray is focusing on the ECU's part. You can see that even if you want to decorate a object, you can actually do so. So in this example, we are defining a counter object. So we can actually construct 4 different remote counters. For each one of the remote counters, here we can do the increment method, called increment method. And of course, like the convention before, you need to dot remote. And then finally, you read the result. It's also a method you can read out. The logic is exactly the same. And at the finally, you get you use the reget to get the result. So everything can do the in parallel and a more efficient way. So it is by design works like you are writing a like a local function, and but almost automatically it make it more efficient and can use hardware that is you use your distributed hardware, very powerful hardware to run everything in parallel. So I think the convenient is unbeatable for Ray. I mean, currently it's one of the choice that can write those kind of things. If you already have an algorithm that run on a single machine, and you want to kind of scale it up, Ray is probably one of easy way to do that. One of the easiest way to do that to scale up your application into different distributed machine and run it parallelly. It's one of the easiest choice that you can have. But you still need to set up. On the more fundamental part, low level part, it can work. It has different way to set it up, but on a more low level part, it can use Kubernetes to integrate itself into the Kubernetes ecosystem and use all kind of Kubernetes provider or machine. Because there are different implementation of the Kubernetes, even in cloud or in local, like a self-hosted Kubernetes. There, even with that, you have different options. But you can also easily use the cloud-based like GKE, AKS, EKS to do this because they are all compatible in the Kubernetes way. So you can use Kubernetes as an abstract layer to kind of switch between different Kubernetes cloud. So use the same Ray API, you can easily apply, enjoy the benefit of the Kubernetes cluster. And you can have your scalable Ray application. Because it is Python based, so everything can be run in Python, can be run in Ray. As long as you set everything correct. So for example, one of the application is use Ray to train things. You can use other trainers like training function used in Hugging Face or in PyTorch or in other things that Python can do. So every worker can run this library and this function. You can use all of this functionality already existed and use Ray to scale up your training into a distributed setting. So that's the Ray train do for you. So there are also other things like Ray train, Ray 2, Ray serve, and Ray alib. All of these are more focusing on the machine learning scenario and the AI scenario things. But even if you are not doing AI or machine learning, Ray can be just if you want a more computational power, you want to scale up your computation, Ray can help you to do that. So let's talk a little bit about this sort of things because it can be routed back to like distributed parallel computation things in all the context and history. But right now, there's HPC, high performance computations. I believe I just remember it's HPC. There's a kind of context called HPC, and the other is called like cloud or cloud native things. They have a lot of interlaps, but they rooted from different culture, like the difference between clustering and clouding. But a lot of tools can be used interchange, or they share similar functionality, but because their originate are different, the feature they are going to and their like the characteristics or properties are different. So the easiest way is to use the popular software exist in that field. It will make things a lot easier because sometimes you didn't even aware of some drawbacks or pitfall of something you need to be really care about, but not easy to be observed things in some kind of application. Or if this software is designed specifically for this kind of application, it might already find out the solution. But if you are using a similar functionality from other culture or other context, although they appears to be similar, there may be some small part like latency or like the robust or security or all these things that is crucial in one application, which is not that important in another one. so they may be overlooked and does not have those kind of functionality in default or even existed. So okay, so let's look back about some of this old software. This kind of old software. One thing is called the remote procedural code. This exists in a long time, maybe since 1970s era. But in 1980s or 90s, they are kind of popular. I think in the 80s they are really popular, but they exist even in 90s. People are still using it. People are still using RPC in general, but the RPC I'm talking about is in the standard C library things, and they are like in some OS, uh, uh, the some OS RPC in Linux they are RPC. So in general, there's I call it Unix It is probably not the right name, but I call it a Unix RPC, the original RPC that I know. It also works kind of like you write the things in one file. You can write the things in one file, and there is a RPC gen tool can generate the actually client and because it is working on the C, so you use an RPC gen to generate actually the client and the server part of the the code, and you can compile it um, into a server and a client. And because it is a remote code, you are when you are in a client, it looks like you are calling a local function, but it actually uh, is in the remote. So it actually has a message. So it has a message define file to define the how to actually kind of serialize the data you are going to pass through. So this is one thing. So GRP, there are also modern RPC uh, iterations. There are RPC implementations. Like even though I'm not sure, but there's also gRPC, which is more like a client server things. But the name RPC probably is the same thing. It just have a prefix G, and there are also like I think RPC lib or other things like a modern explanations of the the old RPC. Also, there is called things called the parallel virtual machine, which was really popular in 90s, maybe in early 2000s. Because you can actually see a lot of the computer systems in universities install PVM as a PVM cluster. It looks more like actually like the name suggests like a virtual machine. It has a command line. You can run some command on it, and it works and looks more like a client server since you have a class right here, and you have a client to call the function and ask the cluster to do things for you, more like that. So it is getting popular in my impression. It's getting popular in 90s and the early 2000s. At least what I know is a lot of um, universities is installing it. What I'm seeing, searching it, and this text come from is here. This is actually from uh, like so you can see if you search for the parallel virtual machine, you'll see a lot like government and university like MIT. It has a PVM guide. Um, you'll see a lot of things in university. The uh, and government area for doing clustering computation. So that is one of the things called parallel virtual machine. But if you search PVM with Python, it will not get you many results because the Python uh, the Python virtual machine is also called PVM. So you need to search with parallel virtual machine Python. Then you can get some packages about the parallel Python, like this PYPVM. There is something. But you can see that the first one is hosting in SourceForge. And so you can say that it is kind of old because it is in a SourceForge, not in a GitHub. So it is sort of old, and I don't see many people use it. Maybe I'm wrong, but I didn't see many people using it. Even if you are seeing search like this one, you are not seeing many. This one is probably a recent one. This one is from another thing called the Parallel, which is a virtual machine, but it's a total different thing. I believe it's a total different thing, right? Okay. Another thing that people still using is MPI. It is a de facto standard, and it has open source MPI implementations. So this one people are still using and doing this. If you click a link, you will go to the Wikipedia page and see it. It probably a lot of exists and they are using it behind the scenes, and but it is still involved and people are using it, still using it. Don't be confused with OpenMP. OpenMP is a syntax in like C++, C, and in C. There's another thing called OpenMP. It is also do the multi, but it is almost like mostly like in the one like a CPU or thing. I mean, put into the English page. So don't be confused with the OpenMPI, the MPI thing. There's also one thing called OpenMPI. So OpenMPI is an implementation of a multi processor interface or something. Message passing interface. So it can pass message from one node to another. So effectively looks like what the remote calling make remote calling possible. So it used a lot in this scenario. But talking about the message passing, there are different protocols and different standards. One of the message passing standard is the AMQP standard, Advanced Message Queuing Protocol. It has been using in a lot of different software because it is a standard. If you are following this standard, you can mix and match the server and client in certain extent. There are also some other protocol like MQTT. MQTT is more used in like IoT things. By comparing MQTT and MQP, is that MQTT is simple. It is a more simple protocol. It focuses on the speed, the performance, and the simpleness. But AMQP support different scenario and paradigm for like a like the publish subscriber since it can and the queuing. You can see that there is a queuing protocol. So it's more focusing on the job queuing, message queuing, or different network topology things. There are many different implementations like Apache, Cupid. You can see that Apache Active MQ. I have used it before, and also like Azure things, MB things, and the RabbitMQ, which is also a very popular open source implementation of the MQP. So sometimes you can mix and match RabbitMQ and Apache Qpid in some scenario. So I'm more focusing on the RabbitMQ because I use it more. I probably have very little experience in all other things, but I know about RabbitMQ. The RabbitMQ has been using in a lot of different softwares. It is very popular and widely used, and it supports MQP 1.0, and also according to the description, this is coming from the official website of RabbitMQ. You can see that it supports MQTT 5.0 as well, but I haven't used that part. So talking about the topology and different applications, here comes from the official webpage of official website of the RabbitMQ. One simple thing is like a queue. You have a provider and a consumer. You can see that producer and consumer, a producer and consumer. There are different terminology in different scenarios, like publisher, subscriber, or other thing. But I believe in the scenario of RabbitMQ, it's called the producer and consumer. So basically, producer produces the image in a queue, in a line, one by one, first in, first out manner, in a first in, first out manner, and the consumer consuming the things in the queue. So in this scenario, there's only one producer and one consumer. So this scenario is quite straightforward and easy. But as you can see that it supports different language like Python, Java, Ruby, PHP, and this is a cutoff right here. There's a lot of different language that is supported by RabbitMQ. And it also works like one producer and many consumer, like this one. So in this scenario, like okay, I have like it's a typical in the first one is more like a client server things, like a website, but websites serve a lot of different people, so it is more like one by one. You can imagine that something that okay, you open a Jupyter notebook on a website, you ask this on a remote server, you ask this remote server to run things. Kind of like that. You ask something, it do something. But in some tests, you require you are trying to parallelize your job into different workers. So you can consider this as different workers. So you have a different job like here. Every worker when they are available, they can take one job from the queue one by one. So this is more like a work queue scenario. So it supports this kind of topology. And another thing is like a publish subscribe setting. The producer produces something, and actually each consumer, each worker has its own queue. Like I have a message, like consider this kind of like a chat app, like Discord or like a chat room. It's more like a chat room. So there are a lot of people participate in this chatting room, in this channel. And when someone is producing or like sending a message, everyone receiving the message. So when the server try to publish something, everyone receive it. So this one does not work. If you are using this kind of network, the server publish a message, only one of the worker, only one of the consumer is getting the message, and all others does not. But in this case, if you publish a message, everyone get the message. So there are also like a routing, since receive message, and you can select which message you should get. So it's more complicated. It's not just okay, everybody get the message. It is selecting which message give to which. So it kind of like a more complicated setting than before. And also there are something like topics. Um, topic setting. It is more. Is another also another pattern. A salary and okay, the Kafka use I think it use topics as well. So these are just different kind of setting, and also RPC is a setting that you actually want to get a reply. So get a request and a reply. So all of there are many different settings, and RabbitMQ support versatile jobs and the setting and the patterns. So no matter what kind of settings you want, it probably is going to is has some support. For example, if you want to do the RPC code, it can do things like this one, pretty similar to what you will do in the like Ray doing. So I'm using this to compare to a Ray, but it is more transparent because the client and the server are more, because you can actually doing this in different language. So client and server are kind of specifically explicitly separated to each other. Unlike the Ray, you can make it easier to write, just like what you're writing in a non-remote local function. But this is very explicitly writing the server and the client using this function call. But anyway, the idea is just serialize the parameters and sending it to a text and getting the result. The result, okay. So also by the messaging passing, there is also something called the LeoMQ, which is also very popular for to use, and it is also open source. One example usage of the LeoMQ is your Jupyter Lab, your IPython notebook, Jupyter notebook, Jupyter Lab is using LeoMQ somewhere in the messaging passing part. It is not compatible to the AMQP, the standard that we talked before, and it's not also compatible to MQTT. But it also support different type of topology and pattern. But it might be a little bit more low level, since at least when I use it, I'm using it in a more low level setting. So it looks like a socket sense. So you have a context right here, then you have a server. You bind a server, almost like what you do for the Unix API, and you have a loop. You receive a message, and when you receive a message, you send a message back. And for the client, you also connect to the server and running these things to send and receive message. The difference is, for writing, it is similar to what the raw socket programming, but I think the benefit, it is more robust and comparing to using a raw socket, and people use it a lot. The efficiency is quite okay. In many scenarios, it is fast enough, but I believe it is not the fastest thing that you can get. But as the name suggests, you might think it is most efficient way and kind of a low level thing. It is, but in certain scenario, they are. I mean, it is not always the best choice, uh, the best solution, for for if you are caring about the efficiency. But this is one thing that you can consider when you want to pass a message, and you don't want to learn too many things. It is just kind of transparent if you're using this way. I haven't used it in more complicated scenario. I It probably has some more advanced API, more high level API or things, but this is probably the only pattern I use for the DMQ, and it is useful. It's quite useful. For the job queue, one of the most popular framework is Celery. Celery is one of the most popular things. It is difficult to search the Google with the keyword celery ecosystem because celery is a vegetable. So if you search celery ecosystem, you will get the actual celery as a vegetable, the ecosystem of that celery as a vegetable. So, but I know that celery is widely used and it's very popular, and it also kind of flexible. It has its own pattern to construct a more complicated message queue system. But at the core, it looks like this one. For the it also like array. You write the client and server in single code base. It is convenient, but when you want to separate the implementation in the server and the API, so the client only know the API, it will get a little bit complicated. It is doable. It is doable, but it is complicated. I mean, all the benefit of Zeri, one of the benefit, most apparent benefit is it is very convenient and easy to use. So if you are not using in another way, in a more low level, it is questionable whether you or not you should use Celery. But when it is applicable, Celery is very flexible and convenient, easy to use. So let's first see how it is using. It has a different broker, which we'll talk about it a bit later. This is the code, the Python code. You write one Python code right here. The server is using the same Python code, but you have a different command line called the celery-a task worker. You can fire up different workers as well, but this one is a worker using this code. So you got a worker right here by using this command line. It will use this code as the to run this server. And for using in a client side, you import it as a module, and you can actually call add dot delay. It also has a method right here to indicate it is a remote function call. It's more like a job queue, not actually a remote function. It's just like a job queue. You give this job to the queue, and this will run by the worker. So this is how Celery works. So if different client exist, they will submit different jobs, and the worker will kind of share the queue and to finish your job. So there is something like called a broker and the backend. The broker means how the message is passing, and the backend mostly store as a storage to save the result. So after the job is finished, you can the result is stored in the backend. But the broker is mostly like a passing message. Okay, so who should do which, and what is the data that is provided in this task. So there are brokers and backends. you can use different software as broker and backend. So you can use RabbitMQ as broker and also use it as a backend. Also, you can use Redis, which we'll talk uh, later in this lecture, and both as broker and backend. It is popular to use Redis as broker. RabbitMQ as broker and Redis as a backend. It's quite popular. But you can use them. If you like Redis, you can use it both as a broker and a backend. If you are RabbitMQ, it's possible to use them as both backend and broker. Also, it supports a lot of different things like Amazon SQS, and but the Amazon SQS is only works as a broker. You can also use other SQL database via SQL Alchemy. So any database supported by SQL Alchemy can possibly used by the RabbitMQ as the backend. The Celery as a backend, or like Celery as a backend. So it is more comparing to RabbitMQ, it's more focusing on the job queuing things, like working things. So one, just recall that you can do things like this one, but it can also be very flexible because sometimes our job is not just putting things in a queue and doing it one by one. Sometimes it has a dependency. We have already relations between different tasks. Some tasks has to be done after certain tasks have been finished. Like if you are doing something like building a source code from a source tree, you have to build some source first and compile some source first and compile something later. And when you want to build the library, you need to have all source code has been compiled. You got the binary files and make them into a library, something like that, and then produce or the final executable binary. So since it has dependency, the Celery has its own pattern to define the workflow, kind of like a deck, and it has something like callback and a lot of different things. So we can one thing is called a chain. We do this one by one. We can chain different tasks one by one, and can use the operator to make it more human readable. You can see that it's a chain, like a piping. We're doing this first, then doing the second, doing the third, and finally we get a result. And as you can see, it can be partial. This is partial application. So you get another parameters from this one. And it also has something like, okay, one thing is everything is in a group. You have a group concept of group, so everything can be computed in parallel and get the result together. So this is called a group. And another thing is called the chart, which means, okay, we have a bunch of tasks can run in parallel, but after all these things is done, we do the other things together. So like before, but we get everything compute, summation them together. So by combining this, there are also other primitives as well. So by combining these primitives, you can construct a really complicated workflow, and kind of like a diagram, like the frozen graph, like representation of the workflow, and you can call this workflow, or kind of like the query plan, like the polars, or like the graph, like in PyTorch or TensorFlow. You can call this graph as a workflow. Another software that we mentioned before is Redis. Redis, we probably already mentioned it in other because it is also popular. The basic usage of Redis is used as a in-memory database. This database is not a SQL database like the SQLite or DuckDB. It is like a more like a key value mapping. So it is storage. It is kind of like a shared memory and storage. So basically, you have a connection to the server, or it has a separate server. You connect to the server, and then you can set the value and get the value. Because the Redis is a single thread, you don't need to worry too much about the race condition thing, like things getting inconsistent. So it is single thread, but it is fast, so it is still very considered to be very efficient. Because it has a very rich object different type structure. One structure is like a mapping itself. Each one of them is a key value, but you can actually define a key related to a mapping. So it can get very complicated. It can construct very complicated data structure, although it might not be not familiar and not be totally compatible with other languages like data structures type system like Python or other like C or other things. The most primitive things is more like I mean a lot of language such support like JSON. This is not exactly JSON. This is not exactly JSON. So JSON, if you want to store JSON into it, usually sometimes it's stored in a string. The string or number is probably the most useful and the fast, efficient primitive type in Redis. But it does have suppose a lot of different functionalities, allow you to choose and use in different. There are different ways to do things, to do things, to do the same thing. Just one way might be more efficient than the other, but there are a lot of different ways to do things, and some it also supports the data type that is more like help the workers or things to be cooperate to each other. So one is that it supports channels. So different kind can subscribe to a channel. So it's more like the publish and the subscribe pattern that we discussed before, like a chat room. It supports some data structure like this one. So every message is stored until every client or subscriber is getting a message. It will hold for a time period. There is also you can doing things like a job queue. So it has a data structure called a queue. So it can be first in, first out, or first in, last out thing, like a stack or a queue. Because it has basically it has no difference. It uses the operator like L push, right push, or L pull or right pull things to do so. So it can be multi-purpose. You can do it like a job queue pattern. So everyone just putting out things out. But it can also do things more strange, because I mean the client has ability to actually check the result without actually getting. It can pick the items in the queue without taking it out. So it has many possibility, and it can be done in a non-blocking way or in a blocking way. When I say blocking, it means when we read the queue, if the queue is empty, should we return it immediately and tell the client, okay, there's nothing in here? Or should we wait until something is coming. They have both methods. You can use both way. So the queue can be used for different job like a job queue or like message passing and different usage method. And all of this combined with the um, memory storage sense, it can be used in a different job. And it also comes with UI and other different UI. This comes from the original company, official UI. So you can, even if you have some doubts or confusion about what happens, what is going on, you can use the UI, web UI to check what is stored in the server and what is presented in the server. You can actually visualize everything. You can actually delete or modify the storage as well. But one thing is that I think although Redis is very popular and widely used, my impression is that it is kind of different to other open source project according to its web page. So you can go to the Redis. I kind of like Redis, but the web page kind of put me off a little bit. The web page does not look something similar to other open source website. It looks like a news website or the style, the things. Okay, and here we know it is a programming things, and but you can see that it focuses on something that like a vector or database things, uh, like vector database or like a real database. I think people use it as a catch vector. They use something like, but like you see in the slide, it is trying to catch up to the more AI scenario things. I don't think a lot of people in AI use it, and the style of this official website kind of like looks like a commercial um, service, not just a software. And the first one get me a little bit confusing. It looks like a service. Get a demo, try for free. Yes, can be free on it is open source, but it's more focusing on the kind of different mindset than the open source things. And you can see that they are trying to pivot and focusing in the AI things because this is probably where the money can come from. The tool, the web UI face is called the Red Insight, which is pretty good. I'll say. For a document, I think a document is a little bit confusing as a programmer. I actually read the document and get useful probably last year, and the last time was probably last year, and I think it's still quite useful. But right now, I couldn't find the good document that I remember, even for the quick starts. I get confused. This is just install it. I have the install is pretty easy. Use the Docker, it will install pretty easy. But the use case is not what I'm familiar with. Uh, maybe so I don't see any code yet. Yes, I can use here to do that. Okay, here's the code, but it is not what I remembered. Maybe it because it is not that Python focused, but it is never just Python. But I think last year when I visited, the document seems to be a little bit easier to read. Also, it has a pricing and get the everything that suggests you that you can only get the full service only if you pay something. If you are essential or free tier user, it is more like a trial or like a preview version. And even if you choose the software, you don't get a download things. Just uh, kind of, it is open source software, but it seems that the webpage does not encourage you to use it as open source software. Community edition suggest, okay, of course you right here you can know how to, it is still got pretty good uh document to setting it up, but I suggest you to use it in dark, using a Docker, because it is a service. You're not going to modify the software, and you can install the Python library, but the library is separate from the, I mean, you can run the server in a Docker and run the Python library quite easy. So you don't need to install it in your, I think typically people run it in a Docker or other virtual machine or in other machine. If you want to use the inside Redis inside, you install this image. But if you don't need the inside, you are already very familiar with Redis, you can only use Redis stack to get everything. I mean, okay, so I got it confused. If you want Redis inside, you install this one, the short one. But if you want the server only without the inside, you install you use a Docker image in this one, and run this one, and as a following instruction, you will get a usable Docker. And everything, every other thing is a Docker knowledge. Okay, so even though I have some complaint about the website, official website, I'm still like Redis and I use it a lot. The efficiency is not something need to be concerned. It is fast enough to do the streaming things, and it is quite easy to use and easy to debug because it has a server to save everything there. So quite easy to use that. When I talk about the, I think when I talk about Dash, probably Dash things, and working with other like Jupyter Notebook or other server, you can see that I use Redis as a communication because it stores things. It's not just passing a message. That is kind of difficult to debug. It stores things, and because it has a message queue, it can serve like a message passing API, and it is more traceable, trackable, and debuggable. It looks like if trying to focus on AI, but I don't actually think I'm not sure people using it a lot in AI scenario, even for rig, but it can use for rig thing. One alternative to the Redis is Dragonfly. It is compatible, mostly compatible, and from my usage, it is definitely a drop-in replacement of the Redis. You can use the same Python Redis module to with this Dragonfly server, which I also run it using Docker, and it is claimed to be much faster than Redis. And from my usage and in the experience, it is faster. However, I believe Dragonfly is also from Chinese company, like maybe Alibaba or something. So just you mentioned that it is a fast alternative. It is really efficient alternative, but I am not sure it is that widely used. In some usage, the efficiency is not noticeable. But if you are really using a lot of data and fast transform, I mean, a very fast exchange of data. That is more the difference is more significant. Although I think from the description it is more focusing, aiming on a different application scenario, like using it as a cache, like website cache things, database cache things, which I am not using it frequently because that is not the things I do. I do things like fast communications between AI model and an interface, or like in a data source, like a streaming from video or like audio things, those kind of things. But still, it is faster. Another backend mentioned in the theory is SQL Alchemy. This is one also a library that used a lot uh, in Python to connect to SQL Server. There are other like SQL object, SQL thing, a lot of different things similar to it. But SQL Alchemy is a ORM system. What is ORM? If you are not familiar, ORM is a way to access into a library, a database, mostly the SQL database, without writing SQL code, and you define the data as a class. For example, we define the user class, so it has different column, like different field, like ID, name, full name. By using the SQL Alchemy object type, it can be annotated into different type corresponding to the data type in a database, and even like a foreign key reference, like a relationship between one object to another. So we use the syntax of like Python class and type hinting and all other things to define the actually relations in a database, in a database table or in a whole database. Then we can use it without the syntax of SQL and do things here to create a table to access to the content of the table. But you can run the SQL Alchemy. Although SQL Alchemy is famous like ORM, kind of like a Django ORM replacement if you are not using Django. But one of the power of SQL Alchemy is as a general SQL adapter to different database. One interface to different database software like Postgres, SQLite, MySQL, ClickHouse, even to a DuckDB or other. Like a Microsoft SQL Server, since like Oracle, it has adapted to different database. So you only need one Python API to access to different SQL database. This is the power of the SQL Alchemy, because even without the ORM, you can access the database in a more low level way. This is a little bit low level, like you define a table itself. It's not like a class or thing, but you can still provide enough information to define a table. Then you can use like the syntax, the SQL builder, kind of a SQL builder things to build the SQL command right here. Build a SQL command right here. It has like a select corresponding to the select syntax in the SQL, but you write it in Python. So you can use Python to write SQL. Kind of like the query language in the .NET. There are some query language things like in .NET. I didn't use Sharp a lot, but I use F Sharp for a while. It also has similar things. So you can use those kind of things to build a query. It can be translated to a SQL query. The benefit is that different databases have different dialect of the SQL syntax. There are some small difference and different semantic here and there. So by using this unified API, it is supposed that it can translate to the equivalent SQL command in different um, in different API. I mean different SQL server, because like Postgres, MySQL have different dialect and different behavior. Sometimes they have different convention of the variable, like capital things or lowercase things. They have different convention. So with this unified API, it will write one code to use different. It made it possible to use one code on different database server. So what the database supported is supported by SQL Alchemy. Here is a short list like SQLite, PostgreSQL, MySQL, MariaDB. They are mostly the same. And Oracle, MS SQL. So probably all of them I have mentioned before. These are just the popular things. Something like a ClearHouse also is also supported by the third-party package. So if there are also like a JDBC or other connected standard. Also, some of them are supported by those kind of standards. So SQL Alchemy can support more than this kind of things. So and even with like Postgres or MySQL, it has different backend for different compatibility and different uh, optimization, speed or support the things that they supported. So there are different. This is quite ecosystem and different uh, software that support and work with SQL Alchemy. Some of the web like Flask or like Fast API doesn't have an ORM system. It can work with SQL Alchemy, so that it can kind of work like a Django. Another message passing, mostly for the streaming, is Kafka. So it has a, I think it is like a topic. The client can subscribe to each topic and get a message, things like that. It is selling for its famous for its robustness and mission critical. Like the speed, the performance is really good, really high performance, for, especially for streaming data. It has a streaming database, which can catch or store a certain time period of the streaming data for you. So you can access to a short time of the period of the data and get a streaming in a very low latency, real time way. As you can see that it is used very widely in certain area that is more focusing on the security, performance, and robust. Another this is kind of a more low level. It's called the airflow. Comparing to like Ray, it is more low level. It can define workflow. Also can like theory can define a workflow. And like Redis, this is a workflow definition by using Python. So we have a hello and airflow. So they have dependency between different tasks. It has like a bash, like a script, shell script bash task and Python task. You can use them, and it also comes with a web UI that you can easily visualize what is happening, what is going on. So it is very good for like defining a job flow, like a workflow, and help you to do things automatically and define it in Python and visualize it. It also comes a lot of different pages to analyze the different performance, different statistics come from this workflow. So this is just one page. It has a lot of UI pages that is very kind of visual and helpful. Another tool comes for quite a long time is Slum. It's called a Slum. If you see, it has been used in a lot of like HPC. Probably one of the most used things like this in this area. There are other things doing similar things, but this one is probably the most popular one. So use as wrong to run your job, and it will automatically manage the resource. So you imagine you have a cluster, have different resources available. So a lot of users trying to submit their job to using the cluster to run the things. So each one is submit their job, it will in a queue. And when the resource is available, the sum will help you to run the resource, and it will check whether the resource is available, and it will allocate the resource for you and to run the job. So even if you have only one machine, like one GPU or like 8 GPU, it is still very useful, because sometimes we are doing training. It will take kind of long time, like like uh, 20 hours or maybe 13 hours. We don't even know when it will start. We have a rough estimation, like it will take like 3 days or 1 day or like half a day, something like that. But we have different experiment which to running, so it can if the training procedure comes with a single like train.py things, by using the sum, it will schedule the things. Like, okay, first we run this training. After this is finished, we run the second one. It can do the latter kind of scheduling for you. So here is from 国网中心, from our Taiwanese TWCC. You can see that a lot of clustering HPC scenario are using this one. The TWCC is also using the Slum as well. So you probably, if you are using the TWCC before, if you are using it before, you probably already use it and familiar. Maybe you are familiar with it. But even if you have just several machine or even just one machine, it can still serve as a pretty okay, useful tools for scheduling the job. So it can has a logic to for this example, it can use it to do resource, to manage resource using command run, use as run to run things, or like different device can run it parallelly, concurrently, or do it when the resource is available. So you can use srun to run the script to allocate the machine to run the things. And this is just a shell script. So the Slum will manage the environment for you. So usually the client will have when I say environment, like the disk or like disk driver, it will actually run in a remote machine, but it will have the same environment, like a file structure or a package installed will have the same thing that you can run in a remote machine, a virtual machine or remote machine. Another popular software is Desk, which we mentioned before, like alternative to a NumPy, like a big NumPy or big pandas. It, because we are talking about array, it also can be considered as another way to run things distributedly. Here is how it runs. We have a cluster and we submit the load and the things in here. This is data. This is data, and we also submit the process and the data to the cluster, and we get the result. And finally, we get all the result. This can be run in parallel. Oh, okay, everything can be run in parallel. So you can see that it's more explicit than and transparent than the array. So you have to control the things by yourself, but it has the ability to use different architecture to run things in a more parallel or distributed way. In here, it runs on the local cluster. This can work in different scenarios, like local, as we showed before, like in cloud or in Kubernetes. It can also use HPC software. Kubernetes is more like cloud. Although you can have something built up on it and making it more like HPC, but uh, I mean the itself, functionality of itself is more like in the cloud native context. But HPC, I mean, what I'm trying to explain is what the difference between Slurm and Kubernetes. They have a lot of similarity, like resource management, like scheduling and interface to invoke a virtual machine, things like that. They have a lot of similarity and overlap in functionality, but they come from different culture and context. So a lot of things they are focusing and the emphasis are different. And these are from HPC scenario like Slurm, PBS, SG, SF, Torque, Condor, and others. I only use Slurm before. Slurm before I heard of them like LSF, Torque, many times, and PBS not many times. But I see here. You can see that I see here. It used PBS. But anyway, you can see that it can use them as like a backend to run your things in a more like a desk way to do that. Here's how it works with Slurm. You can also run it with Slurm cluster to do things like you have a dynamic workload and run it like in this way to call the worker to do your things. So as I think the benefit, I mean the good point, the strength of the desk, it support different kind of things, not only just like a big array, big data frame, or distributed framework, distributed computation. It works all of them. So it can focus on doing things like the Spark, which is also a very popular software for the big data. But I didn't put it in this list. But PySpark is actually really good to doing certain kind of query in parallel in the distributed setting. But this is mostly for the big data scenario. So Desk can do similar things like in big data things here. So for example, what I mean by big data is like you have a really big database. You want to do see, okay, for a simple thing like, okay, we have a column, but this column is separate in different part of the database distributed system. Wanted to sum up all these column together. Then this is a task, or try to compute the mean of this column. But you have like billions of billions data separated in many different machines. So this is some kind of task of the big data, or something more difficult, like, okay, pick the topmost, I mean the largest, topmost top 5 largest number in this column. This is some kind of test. You want to search into the database and find the result, and to find the exact result, not just using some statistical formula to do that. Sometimes you have to do so, but in this case, you can actually do it in a distributed way to find the actual result. So Spark can do that, and the Desk can also do similar things like this one. So because I didn't put, so there are definitely a lot of things like PySpark is actually pretty good things that you can use. So I definitely didn't put everything, include everything here. But the last things I want to emphasize is that when you choose, you are definitely going to learn more software when you start your career, or when you working with your paper, or do thing. If you are going further, if you are not stopped or quitting, you are definitely going to learn things after like 5 years or 10 years. So one thing in these lectures, the takeaway from this lecture is you can see that I introduced a lot of different softwares. There are just too many. So instead of teaching the details like tutorial on NumPy one by one like what we did before, or teach you every single trick in pandas, or transforming in polars, or like PyTorch, uh, hand by hand, step by step teaching the PyTorch. Instead of doing that, I mostly wish you to have a test, or like knowing how to learn the new things, because you definitely will going to learn new things. A lot of software does not exist like 10 years ago, or like Ray Desk. I don't think they definitely not exist like 20 years ago. Even there is like 10 years ago, they are not probably not that popular. Like Torch is probably started from like 2017. It's not even 10 years ago. So we are going to definitely to learn the new things. So we cover things that you, how to quickly to learn new things from the official website, official tutorial. So we look into the official website a lot. Like the Redis, I am going to have, I did have some complaint about their website. But for other website, we went through as well and see which part you should look. The reason is the thing is getting new. Your learning is new. They probably don't have a very good textbook, or even if you have some book, they're going to be outdated really fast because the things changes really quick and a lot. So if you want to learn things, and even I mean the author of the book need to learn things from somewhere, right? Some people writing a blog, they need to learn things from somewhere. You can actually learn this from the official documentation, or reading from the code. So that's what we encourage you to do so, and actually getting the vibe or the trend of every software. So one thing is that ecosystem is really important, because there are a lot of softwares you need to learn. So which one you should learn? Observe the ecosystem. If it has a robust ecosystem, it is going to win the war and get to the market. If you see the healthy ecosystem, and you can through the ecosystem to learn other important component, other software in this ecosystem, from one to learn many related software. So all the successful software framework has an ecosystem, and they emphasis and focusing on the ecosystem, including the Torch we talk about, the Pandas, Polars, Rust, and we probably didn't cover NumPy, or like beyond NumPy is so popular. It doesn't. It is the ecosystem of ecosystems. It doesn't matter. So about the software we talk about today is like a desk. It has an ecosystem. In its official website, it has a page about the ecosystem. It talk about how the array. Some of them we actually talk about like data frames, like CODF, for the CUDA, for the array, and for the SQL, For the machine learning, it has things to do with machine learning, like XGBoost, like GBM, scikit-learn, and for deploying, it has a lot of things that work with it. And for the Ray, it also has a page about its ecosystem. It can work with Airflow, which we mentioned before, and Buildflow, other things like this like Flowpoint Desk. It even work with Desk and Hugging Face. Um, a lot of I haven't got Intel things. Like the PyCaret we mentioned in the scikit-learn things, and the scikit-learn itself, especially is for the natural language processing. And okay, of course, like XGBoost, like GBM things, it has a really good ecosystem, and they are actually very focusing on it because they put it in the first uh, order here, in the first level. And Kafka also has an ecosystem in its official web page. Of course, it is in the Apache family. It has a brand of Apache, but it also has a page about its ecosystem and like Hadoop integrations and other stream processings. Okay, so do not just run one software and learn the ecosystem. Okay, so this is the all about this semester's lecture, and I hope you have a good grasp and fun for doing data science project.